Yo, what's up? It's Mr. Cho, right? And today we're going to go through the second book, right? The one in green of your science exam. Okay, so let's get right into it. Okay, so the first chapter is talking about the sources of food, all right? So we need to know about how to grow food and why do we need to grow more food. So firstly, what is where does food come from, right? Most of it is from plants, right? And so we need to know this equation, right, called the photosynthesis equation. So we know that we need, what are the things that we need for photosynthesis? We need the carbon dioxide, right, that is found inside the air over here. We will need water. Then you will need sunlight, right, together with sunlight, and also the soil, right? Soil is important. We need the nutrients in the soil, and for the soil to have the right pH. Usually it's about the neutral lah, right? The pH should be neutral, not too acidic and not too alkaline. Okay, so with this, right, carbon dioxide plus water plus sunlight, then we can have the photosynthesis equation. What do we get? Right? What does the plant make? Right, we got sugar, right, in the form of this thing called glucose, as well as oxygen. Okay, and that is why it's important for the plants to do photosynthesis, right? Firstly, we can eat the plant, we're eating the sugar. Secondly, we can use the air, and the oxygen that the plant has produced for us to breathe. Okay, so let's say a farmer, he wants to measure the pH of his soil. He wants to make sure that it's near to maybe pH 7, make sure that it's not too acidic, not too alkaline, so he can grow his plants properly. He can use a few different methods, right? He can use litmus paper, universal indicator, or a pH meter. Okay, so let's talk about litmus paper first. We got two types of litmus paper, right? Blue litmus paper and red litmus paper, right? Both of them can be used to measure the soil. So if let's say I start with a blue litmus paper, right? I take a blue litmus paper, and then if the soil is acidic, right? If soil is acidic, then the blue litmus paper will turn what color? It will turn red, right? It turn red. So like that. Okay, then it turn red. Okay, but what if I start with, what if I have a blue litmus paper and the soil is alkaline? Then it will remain blue, lor. That's it. Right, it just remain blue. Okay. Then of course the other kind of litmus paper will be the red litmus paper. Right, red litmus paper. Right, if you put it inside a alkali, right, another way of saying alkali is also to say as base. Right, then what happens to the red litmus paper if you put it in an alkali or base? Right, it will turn blue. Okay, so remember the colors, right? Red usually stands for acidic, and blue usually stands for alkaline. Okay, now let's talk about universal indicator. Okay, so this one you need to learn a few, two more colors. So same thing, right? For universal indicator, if it's acidic, right, what color do you normally see? Right, it'll be like reddish or orangey or yellowish, right? Usually, the more acidic it is, the more red it becomes. So maybe orange would be, red will be like pH 1, pH 2, pH 3. Then orange will be like pH 4, pH 5. Then yellowish will be like pH 6. Then what if it's neutral, right? Neutral is pH 7, right? pH 7. What color do we see for the universal indicator? That's right, you will see green color. Okay, so the default, that means that by itself, the universal indicator, when it's neutral, it should always look green. Okay, some of them will look a bit brown, but it's called as a brownish green. Okay, then what if it's alkali, right? If you put a drop of alkali in the universal indicator, then you will expect to see either a blue color or even a violet purple color, right? So the more alkali it is, the more purple it will look like, or the more violet it will be. So maybe blue will be like pH 8, 9, then pH 10, 11, 12, 13, 14. This will be more of the violet colors already. Okay, then of course pH meter is easy lah, right? Very simple, right? Any number between 1 to 6 is acidic, right? And then any number that's just 7 is neutral, and then any number that is above 7, right? So basically 8 to 14, these are going to be the alkali. Okay, alkali. Okay, then we talk about fertilizers. Okay, so fertilizers provide the nutrients needed for the plants to grow faster and bigger. Okay, so what do fertilizers contain? Most of the time, fertilizers contain this thing called phosphate. Okay, phosphate. Now, phosphate is good because plants need phosphate, right? Usually, there's two things: phosphate and nitrogen, right? They need these two things in order for the plant to grow fast and to grow big. Okay, but these can cause problems also. Okay, so fertilizer can be beneficial because fertilizers help to increase the food supply, right? They allow you to grow more food, right? And then you can feed more people. But they can also cause problems. Okay, what is one problem? If, for example, the fertilizer, right, you put too much fertilizer in the soil, it can cause what it calls an algae bloom. Okay, so what's algae bloom? Let me just show you a quick picture of it. It was like that lah, right? So you say, hey, I never put my fertilizer into the water. Why suddenly the water turned green? It's because this fertilizer, it can flow from the farm into the sea. Okay, so if the farmer not you, sorry, if the farmer put too much fertilizer, then it can overflow or overrun into the sea and cause an algae bloom. Then what's algae bloom? Right, all these green algae, they will block the sunlight and oxygen from entering the water. So if there's no sunlight and no oxygen that can enter the water, how will the aquatic, right, the sea creatures survive, right? It's the fishes in the sea, and also plants are in the sea. So if there's no sunlight, then the plants will die. So aquatic plants and fishes will die, right? Because there's a lack of oxygen. So it's all because of this thing called algae bloom, right? Without when there's too much of the fertilizer that go into the water. Okay, next we need to talk about slash and burn method of agriculture on soil fertility and the environment. Okay, so what is slash and burn? Slash and burn, very simple, right? You got a forest, right? You just start a fire, burn it up, and then after that, all the trees, you can just like slash it down, right? So you cut, and then you burn everything away. Okay, so it's very fast, it's efficient, right? So it's cheap, it's fast, it's efficient, but there is the negative effect, right? Firstly, it causes haze. Haze can spread, right? Maybe from other countries, can spread to your country, right? Oh yeah, I forgot one good thing about the slash and burn is that it actually provides nutrients to the soil. Okay, what I mean is that when all these ashes, right, the ashes they actually go into the ground, and then the next generation of plants, right, the seeds, they can actually use the nutrients in the soil to grow. Okay, so back to the bad thing about slash and burn, right? It causes haze, right? Haze. Then what can the haze do? Yeah, it reduces your visibility, so there might be a higher chance of road accidents, right? Drive the car, cannot see. Like people with asthma cannot breathe, right? They are able to trigger the asthma in people. Okay. What else can slash and burn do? It right also cause soil erosion. Okay, because you know the trees, right? The roots, right? These are the roots of the tree. They actually hold the ground firmly, right? So without the roots, if all the roots are gone, then the ground becomes very weak, right? And very loose. If the rain comes, then the soil can just be eroded. Eroded means like washed away by the rain. Okay, soil erosion. Okay, so that's the good and the bad of slash and burn. Okay, now let's talk about pesticides. What is a pesticide? A pesticide means something that kills a pest. Okay, so things that are pests are things like locusts, right? That are going to eat all the crops. So insects that eat the crops, right? And you don't want that to happen to your crops because you want to protect it. Okay, so herbicides, what do herbicides do? The word herb, right? It means something that's like a weed. Weed are like small little plants that grow on your other plants, and then they suck up the water and they suck up the nutrients from the soil, and they don't let the plants that you want to grow properly, right? The crops that you want to grow. Okay, so it kills pesticide kill pests, herbicide kill weeds. What are their negative effects though? Is that these two things, pesticide and herbicide, they can cause soil and water contamination. That means that once again, if you use too much of it, you will contaminate the soil. If you contaminate the soil, right, it will actually have a harmful effect on the food chain. Okay, so it can cause what you call as a poisoning. Alright, can cause poisoning even for people, right? If you drink the water that is contaminated with this pesticide, right, you can get food poisoning. Okay, and then of course for the animals, right, having too much of this pesticide in their food chain, right, will cause poisoning lah. Basically, there's too much toxins inside their body, and then they will die. Okay, next, describe and explain the use of biological control to reduce the need for pesticides. Okay, so pesticide is a chemical, right? You need to spray all these pesticides around. So an alternative instead of spraying pesticide is to use biological control. For example, there are too many worms that are eating up the crops. So what can you introduce? Right, you can use their natural predator. Right, maybe for example, you take a chicken, so the worms are eaten up by the chicken. Right, eaten by the chicken. Right, so then there's less worms, and the worms will not eat your crop. Okay, another example with this thing called aphid. Okay, what's an aphid? It's a insect. Okay, it's this small insect that will eat the crops. Okay, so what eats the aphids? Okay, so what eats aphids? Okay, you can use ladybugs. Right, so ladybug will eat the aphid and then can reduce. Okay, so ladybug eaten up by aphid, and then you will reduce the number of pests in the crops. Okay, so this is called biological control. Okay, then why do we need to improve the food production? Okay, there must be a reason, right? You know, you want to grow food for a reason, not just for fun. Firstly, it's because the world population is increasing, right? As of last year, right, 2023, the world population is already 8 billion people, right? 8 billion is a lot. So because of more and more people, we also need to improve the methods of food production. Now, secondly, with climate change, global warming, right, a lot of countries are suffering from drought, from flooding, right, and all kinds of other problems. So there are lesser and lesser space to grow food, right? There's less farmland, right, that is able to grow food. So how do we counter these two problems? Is by using these new technologies, right? Firstly, we can improve the plant and animal variety. Okay, what does that mean? That means that you can introduce better quality crops, right? So you might have heard of like this thing called modified plants, right? For example, the rice is better quality, it can grow faster, it's more durable, it's less likely to be eaten by pests, right? That's called the improving the animal and plant variety. And you can also use things like intensive production methods for crops, fish, and farm animals. Okay, I won't go into detail of them, but I just know this word intensive production. That means like, you know, if you imagine like a farm, right? Those are olden day farm, no longer in favor already, right? Nowadays we're all using the modern technology, right? There's all the conveyor belts lah, there's all the different ways of farming it faster and farming it better. So those are called intensive production methods. Okay, lastly, plant hormones. Right, so do you know what are hormones? Hormones are actually substances that are in the body, right, be it human or plant, that help to regulate your growth. Okay, so for example, the human growth hormone, right, it allows you to grow, you know, big and then tall lah. Right, so all of us have these hormones in our body. Okay, but plant hormones, they can be used in 3 ways, right? Firstly, it can be used to kill weeds. So what do I mean by kill weeds? Remember, weeds are like small little plants. Let's say this is the plant you want to grow, on sunflower, right? Sunflower. And then there are small little weeds that are growing around the sunflower, right? You don't want that, right? All these are like sucking up the water and the nutrients from the ground, right? It's stealing it from your sunflower. You don't like that. So you will use this plant hormone as a weed killer. What does it do? It actually forces these weeds to overgrow and suck up all the water. And as it does that, right, then it will actually kill the weed first. Your plants are more durable than these weeds. So these weeds will die first. Then once they're dead, then you can stop using the weed killer, the plant hormone, and then the plants can grow back to normal. Okay, secondly, this plant hormone can be used to regulate growth. Okay, so you put the correct amount of plant hormone, then your plant can start to grow properly, right? All the sunflower seeds come out. Okay, and then lastly, can ripen the fruits. So for example, banana. Banana when it's not ripe, right? What color is it? It's usually green color. But you can use this plant hormone to help to ripen it faster, so that from green it can turn to yellow, and then you can start to eat the fruit already. Okay, so 3 things: weed killer, regulate growth of the plant, ripen the fruits. That's called plant hormone. Okay, next chapter, food chemistry. Right, so in this chapter we learn about the different separation techniques. Right, then we learn about some chemical changes that produce new products, and then the acids in some food. Okay, let me just drink some water. Okay, we are back. So we are going to talk about 5 different separation techniques. The first one is very easy. Okay, the first one is just dissolving. What is dissolving? Basically, you take something that's soluble, right? Something that's soluble, and then you can dissolve it. What is something that's soluble? Things like sugar, things like salt. These are all things that are soluble. Just put inside water, stir, and then you can dissolve it already. Okay, what is filtration, right? Filtration is very simple also. It's like, for example, if you have a piece of filter paper, right? Filter paper, and this is a filter paper, and then when you put something in the filter paper, okay, I show you a picture lah. Show you a picture easier. Right, filtration. Okay, like that. Okay, so here you have some substance. You have filter paper as well as a filter funnel, and at the bottom you have a flask. Okay, so usually the filtration is done for when you have a mixture of something that is soluble and also something that is insoluble. For example, salt water and sand. Salt water is soluble, right? The salt is dissolving in the water, and then the sand is insoluble. So the sand will be trapped in the filter paper as what you call as a filtrate. Filtrate, filtrate, right? What am I saying? I'm so tired already. Sorry. Okay, sorry, it's not filtrate. Filtrate is the thing that actually go through. Right? The thing that is trapped behind is called the residue. Okay, so filtration, residue. Right, this is what I mean. Okay, so the thing that's left behind is the residue, and then the thing that passes through will be the filtrate. Okay, so that's filtration. Then what's evaporation? Evaporation is simply when you use heat to evaporate the liquid. So, like once again, it's a very simple procedure. Evaporation. Okay, so it's just when let's say like that. Okay, so let's say you have a mixture of salt and water. Okay, so you want to evaporate. The salt will not evaporate, but the water will evaporate, right? So you start to heat it up, and then the water will start to evaporate, and then left behind with the salt crystals in the evaporating dish. Now just something to take note of. This is not exactly the same as boiling. Okay, when we say boiling, we refer to boiling water, and that is like at that temperature 100 degrees Celsius. But actually evaporation can take place at a lower temperature than 100. So for example, if you see here, the ocean, right? The ocean water can evaporate, right? But the ocean water is not boiling. So actually evaporation can actually take place at any temperature, right? Even if a low temperature, it can still evaporate the water. Okay, so that is evaporation. Okay, then what is distillation? Let's take a quick look at the picture. Distillation diagram. Okay, so distillation is usually done to separate either 2 liquids or a liquid and a solid. Okay, so in this example, we got liquid and salt water. Okay, so salt water is the thing that we are burning, we're distillating. So you will have a fire below, right, to provide some heat. Then the water will evaporate, and then as it goes up past this thermometer is to read the temperature of the water vapor, or whatever vapor that is passing through it. Then the vapor or the gas, it will move through this thing known as a condenser. Okay, the condenser is filled with cold water. Cold water is pumped in from the bottom, and then the cold water exits from the top. So this, right, will help to cool down the water vapor, and then as the water vapor cool down, it turns back to a liquid droplet over here, and then it will be collected in a cup, and this is known as your distillate. Right, and this distillate is basically going to be your pure water, right, also known as distilled water. Okay, then what will be left behind in this flask will just be the salt, okay, or the other things that are not evaporating. Okay, so that is distillation. Okay, last one, paper chromatography. Paper chromatography diagram. Okay, so paper chromatography diagram, once again, is also quite a very simple procedure. Let me find a good picture for you. Okay, so I found some better pictures already. Alright, so let's look at this picture first. Now, what is chromatography about? Right, firstly, chromatography is just a very simple way of separating inks into its component. Okay, so inks, right, you see the colors, right, it's not just one color. For example, black is actually a mixture of different colors. Right, for example, green is actually a mixture of other colors. Right, so you can actually separate them using chromatography. What happens? We start with some liquid, right, called the solvent, and then with a piece of paper called the chromatography paper. We have the different inks, we put them on a single line. Okay, and this line is always joined with a pencil, because pencil is insoluble, so that this line don't run. Only the ink will move up. And the ink is soluble, right? So when the ink is soluble, when the solvent goes up, right, the solvent actually will go up because of this thing known as capillary reaction, right? The water will be pulled up. As it's being pulled up, it will also carry the dye with it. And the further the dye go, right, that means that the dye is more soluble. If the dye is not very soluble, it will stay or will not move much. Okay, so let's look at one example. If let's say we have different inks, right, A, B, C, D, E, and even F, right, some of them you can actually combine inks together to make a new ink. So let's look at, for example, C, right, there's 4 dots over here, right, these 4 dots. Where did these 4 dots come from? It actually came from 2 other dyes. So what are the 2 other dyes? What do you think? Okay, that's right. The answer is A and E. Because as you see, right, these 4 dots, right, is actually equivalent, right, the same height as the dots that are in E as well as the dots that are in A. So when you combine A and E together, you can make this C, this kind of ink. It's just like when, for example, you mix a red and blue together, then you get a new color, right? You can get purple color. Yeah. Okay. So that is paper chromatography. Okay. Now let's talk about the applications of the various separation techniques in the home and food industry. Just give me a moment. Okay, so sorry, I had to go do something. Okay, so these 5 methods can all be applied in your home and your food industry, right? For example, if you do cooking, if you do any kind of food industry related things, you will need to know all these 5 techniques. Okay, now let's talk about using a measuring cylinder. Okay, measuring cylinder is not too hard, but how do you read measuring cylinder? Okay, so let's take a look at this example over here. Okay, so you notice that when you have a measuring cylinder, the water don't always form a straight line. Sometimes the water actually curves, right? And this is what you call as a meniscus. So when we are looking at the measuring cylinder, we need to look at it at the eye level, right? Eye level, so that you will prevent any parallax error, right? So I write over here, prevent parallax error. Okay, so we need to prevent parallax error or avoid the parallax error. Okay, so anyway, how to read, right? Firstly, always start by reading the bottom and the top. Never ever just read one, right? If you only read one, you will start to get confused. And so you always read the bottom number as well as the top number. Okay, and not always you think it's not always going to go very nicely by 1. Sometimes it can jump by 2, sometimes it can even jump by 1.5 or 2.5 like that. Okay, so read the bottom, read the top, and then count carefully, right? 60, 61, 62, 63, 64, 65, 66, 67, right? 67. Read the bottom of the meniscus and then that will be your answer over here. So this has a volume of 67 ml, also can say 67 cm cube. Okay, so that's how you use a measuring cylinder. Now, we need to describe a chemical reaction as a process that leads to a formation of new products. Okay, so that is very obvious lah. Right, so basically what's the difference between chemical reaction and physical reaction? A physical reaction is just a change in the state. For example, ice, right, melt, become water. That is still water, right? Technically it's still the same chemical. Okay, but if I actually pull apart H2O, right, water, I pull apart the hydrogen and I pull apart the oxygen to make hydrogen and oxygen, then that is a chemical reaction already, right? They are splitting it up and then you got new products. Okay, another example would be like mold, right? When you got mold on your bread, right, you start to smell it, very smelly, right? Why is it smelly? It's because there's actually some chemical reactions that the mold is doing to the bread, is breaking it down, decomposing it, and so you will smell this kind of chemicals, gas that are smelly to your nose. Okay, so anything that creates a new product is a chemical reaction. Anything that does not make a new product is just a physical reaction. Okay, so like I said, decaying of food, the moldy thing, right, or even the sour milk, right? The milk, right, when you leave it in the open, bacteria comes in the milk, it turns it sour. You can even smell the sour milk because it's actually decaying. Okay, when you cook food, right, the egg, right, you cook the egg, right, actually there's some new chemical reactions happening inside, and therefore the egg is changed. Okay, burning, right, you burn a piece of paper, right, it's changed already, right, it becomes ashes, right, the ashes is actually carbon, so that's why it's a chemical reaction. And then lastly, rusting. Okay, so if you leave a piece of iron in the open, right, water in the air will make it rust, and then it will turn like, you know lah, rusty got that brown thing, right? Actually it's because of the water and also because of oxygen in the air, right? Oxygen is actually the thing that causes it to rust, because it's called iron oxide or something like that. Okay, so we need to give examples of everyday situation in which slowing down or preventing chemical reactions. Okay, so what are some examples? Firstly, preserve food. Okay, so if we use preservatives or even things like pickling, okay, remember you put your food in vinegar, right? This will actually help to preserve your food, and so you can keep your food for longer. Okay, then reducing the amount of heat also will help to slow down chemical reactions, because usually heat is needed for chemical reaction. Then if you reduce the amount of fuel and air for burning, then that also slows down the rate of burning lah. So you can't burn as effectively, so it slows down the rate of chemical reaction. Then what is tin plating? Okay, so tin plating is basically you line your metal with a thin layer of tin. Right, tin is also a metal, but tin doesn't rust, unlike iron. Okay, so basically let's say you got iron bar, you coat it with some tin, right? That's called tin plating. You actually protect it from rust. Okay, another way of course is just use the simple paint lah. Normal paint also will work to help prevent rust. But the bad thing about that is that once the paint peels off, then the metal, right, even you look at your table and your chair, you might see that some parts of it is rusting already. Okay, next, describe the properties of acid by their taste and their effects on litmus paper and universal indicator. Okay, we already said this, but we will know acids taste what? Do they taste bitter? No, they actually taste sour. Okay, what's the acid effect on litmus paper? It will turn the blue litmus paper turn red, and of course if it was already a red litmus paper, then it will remain red lah. Okay, then what does it do to the universal indicator? It would turn from green to red. Okay, so you turn the universal indicator from green to red. Then we have described acidity, right? Anything that's below the pH of 7. Neutrality must be exactly 7, and usually the only liquid that is neutral is water. And then alkalinity, right? Anything that's above 7. So things like your soap, things like bleach, these are things that actually are alkaline. Okay, so measure the pH of various common household substances and food using homemade pH indicator, litmus paper, universal indicator, and pH. Okay, this one already covered already. Okay, we need to relate pH within the mouth to its effect on dental health. Okay, it's quite important one. Okay, so why does our teeth decay? It's because bacteria produces acids. Right, so the bacteria that is stuck on your teeth, right, the little plug things, like the sticky thing on your teeth, those are the bacteria. They produce acid. And so firstly, of course, you need to brush your teeth to remove off the bacteria from your teeth. But besides that, right, your toothpaste contains, yeah, it's usually alkaline, right? Toothpaste is alkaline. Maybe the pH is about 8 or maybe even 9. Okay, usually not too strong lah, just a mild alkaline. So why is this toothpaste alkaline? So this will neutralize the acid, prevent tooth decay. Okay, because the acid is the thing that would actually cause your teeth to have decay, and then got cavities. Cavities are small little holes in your teeth. Okay, next we need to describe the properties of food acids on the following item that are found at home. Okay, metals. Okay, so most metals, when you have acid, okay, this is what you call as the 3 acid reactions: metal plus acid, base plus acid, and carbonate plus acid. Okay, so what do I mean by this? Let's do a quick picture over here. When you have acid plus metal, right? So any metal, like for example iron, for example copper, or even more reactive metals like magnesium, right? Then you will actually get a reaction, a chemical reaction, where you produce this thing known as a salt. No, when I say salt, I don't mean the thing that you eat in your food, that salt. It's actually a different kind of salt. Okay, but for now we can just call it as a so-called salt. Okay, so acid plus metal is equal to salt plus hydrogen. Okay, now remember, you can actually test for this hydrogen gas using a certain technique. Let me show you a quick picture of it. So here is okay, so we really start here. We will take some metal. I just show the video. Take the metal, you put in the acid. You see what happened to the magnesium? It's a metal. Okay, so you see all the bubble. What gas is this? What gas is this? This is actually the hydrogen gas, right? That's being released. Okay, so the hydrogen gas is all trapped inside the test tube.
And the gas is given off. In order to test for the identity of the gas produced,
okay, so what is the test for hydrogen?
over the Bunsen burner.
Okay, we need to have a lighted spleen, a lighted wooden spleen. So you see a Bunsen burner, you light it up, lighted wooden spleen. Then you open up the mouth of the test tube.
What do you think will happen next?
Do you hear that? You catch that pop sound? Okay, let's watch it one more time. Okay, that sound not from me. That one's from the reaction. So you hear a pop sound, right? And sometimes, most of the time, actually the lighted spleen will actually no more fire, extinguish. Okay, why is that the case? It's because the hydrogen, when it reacts with fire, it actually will cause a pop. Okay, so you can test for hydrogen using this method. Okay, the second reaction is called acid plus carbonate. Then this one is, you will get the products called salt plus carbon dioxide plus water. Okay, take note this one got water. Now there's no test for water Actually there is a test. Sorry, it's called the cobalt chloride paper test. Okay, but anyway, do you all know how to test for carbon dioxide? Okay, what's the test of carbon dioxide? Very simple. It's called the lime water test. Okay, this one don't show video. This one is very simple, right? At first you got like this. You got a clear liquid. This is called lime water, right? You remember you put when you blow when you bubble gas, right, carbon dioxide into the lime water, then it will turn white, right? Cloudy white, precipitate actually, cloudy white. So this means that there is carbon dioxide. Okay, so that's the second equation. And lastly, acid plus base or acid plus alkali, same thing, will give you salt plus water. So notice something interesting here. Acid and carbonate gives you water, acid and base also give you water, but acid and metal, that one, it does not give you water. Okay, so why is this the case? This is just a chemical reaction. You need to memorize these 3 things. Okay, So you need to memorize these three. What will the acid do to the metal? Acid will actually corrode the metal, and in what way? Because we saw that video just now, right, where the metal is actually being corroded and then it's giving out hydrogen gas. So in the same way, right, the acid would corrode the metal, and then it would cause the metal to become useless after a while on the cooking utensil. Then what is an antacid? An antacid is basically a pill that you eat when you got gastric problems, right? You got gastric pain, and then this basically means that you got too much stomach acid, right? Your stomach actually produces this thing known as hydrochloric acid, and its pH is very low, pH 2. So if let's say you never eat food, right, one whole day you never eat enough food, or you keep having very bad eating habits, then your stomach is like producing incorrect amount of acid, then you're starting to get gastric pain and stomach pain. This is when you need to take antacid. Antacid will actually neutralize the acids that are found in your stomach, make it to a more neutral pH, and then it will prevent your stomach lining from being damaged by the acid. Okay, of course you cannot eat too much antacid because then you'll go over the limit already. Okay, so what's carbonate? Carbonate is found in baking soda, right? So when you bake food, right, bake the bread, you put in some baking soda, right? Actually, so when you are baking the bread will grow, expand. Why is it expanding? It's actually because of the gas bubbles inside. There's a lot of small little gas bubbles. You actually look at your bread, you'll see all the small little holes in your bread. Those are actually created by the carbon dioxide that's being released from the baking soda. Same thing for the vitamin C tablet. When you put your vitamin C in the water, right, and you see all that kind of thing come out. Actually, why is there so much gas? Right, it's because of the carbon dioxide that's being released. Okay, so lastly, we need to state that neutralization takes place when an acid reacts with a base, and then that the products are salt and water only. Okay, so this is exactly what we have been saying in this here, right? Acid plus base is equals to salt plus water. This one must just memorize, right? No choice. The more I explain, the more confusing it gets, so just memorize it. Okay, 3 more things on this chapter. We need to state that some applications of neutralization, for example, toothpaste, which I already explained just now, fabric softener. Okay, so fabric softener, what is fabric softener? It actually contains a small little amount of acid, right? Small little bit of acid to have to soften the clothes. And then what is hair conditioner? Okay, so hair conditioner, right? Our hair needs to have have the correct pH, right, in order to be healthy. So when we use shampoo, some of the shampoo is actually a little bit alkali. Okay, so if your shampoo is a little bit alkali, if you leave your shampoo on for too long, it actually can cause damage to your hair. So this hair conditioner the hair conditioner is actually going to be acidic in order to neutralize the shampoo. Okay, and that's how not all right? Nowadays a lot of different products, but some of the hair conditioner work in this way. Okay, neutralizing industrial waste. Okay, basically you just need to know that these are all the ways that neutralization can be used, right? There's a lot of different ways: toothpaste, softener, hair conditioner, industrial waste. Okay, so we have also discussed about this phosphate detergent. Remember, we've talked about phosphate, right? This is something that actually plants and algae they use to grow. Okay, so when you got too much phosphate in the water, it will cause growth of algae. Remember what we just learned in the previous above, right? It was that this will cause algae bloom. Algae bloom block sunlight, block the oxygen from dissolving into the water, and then without enough sunlight and oxygen, then the aquatic plants and fishes will die from suffocation. Okay, so that is why these phosphate detergents are bad. And also, why is acidic wastewater bad? Of course we know right? The fish need to have a the correct level of pH in order for them to survive. So we cannot have acidic wastewater that goes into the river and sea. Okay, microbes. What are microbes? Things like bacteria. Things that are very, very small, but you cannot see with your eye. So why do we need to use microbes to treat wastewater before it is released to the river? Like what I said, microbes can actually reduce contamination. Okay, they actually reduce contamination, and this is why you can use the microbes to treat wastewater before it is released to the river and sea. Okay, now let's move on to the next chapter. Right, the video quite long already. Okay, so last chapter for this section. Yes, last chapter for this section. Okay, we need to talk about how food contains carbohydrate, protein, and fats. And then we need to have a balanced diet, food labels, action on microbes, preserving food, and then the pros and cons of food additives. Okay, so A, we need to understand the concept of a balanced diet as a diet that supplies sufficient quantities of carbohydrate, protein, fats, vitamins, mineral salt, fiber, and water. Okay, so I'm just going to say very quickly the function of each of them. Carbohydrate, right, is a source of energy. Okay, so when you eat things like bread, rice, these are sources of energy. Then, what is protein for? Protein is for growth and repair of your body. Okay, so things like chicken, cow, beef, these are all protein. You use it to grow and also to repair your body. Then fats, right, come from oils, they come from other cheese, etc. Okay, things that are oily. Okay, so what do fats do? Fats actually help soluble. They help to dissolve things in the body, and they also are a source of energy. Okay, so let's say if you don't have enough carbo in your body, then your body will start to use the fats as a secondary source of energy. Okay, then we got vitamin C that comes from fruits like citrus fruits, right, oranges and other fruits. Then also got vitamin D, right, and that one comes from fish oil. Okay, so what is vitamin C for? Right, mainly to help protect your gums, right, prevent your gums from bleeding, and to boost your general body immunity, right, your white blood cells. And what's vitamin D for? Vitamin D also helps maintain your body health, and it is important for your skin also, right? That's why you need to go out and get some sunlight for your skin to have enough vitamin D. Okay. Oh, I forgot about one more thing. Vitamin D, it also helps to make your bones stronger, because it actually allows the calcium to enter into your bones. So that's what vitamin D do, right? It actually allows the calcium to go into your bones better, more efficiently. Okay, mineral salts. Mineral salts, you got iron. Okay, and then iron, right, is needed, right, to produce red blood cells. Okay, and then we got calcium. Calcium is needed for strong and healthy bones. Okay, then what about fiber? Fiber is important to help us to prevent constipation, right? Basically help us to pass motion. Okay, pass motion means take a dump. Okay, where do you find the fiber? It's found inside fruits and vegetables. Water also helps to prevent constipation. I can't spell already. Never mind, very stressed already. We'll move on. Okay, so water helps prevent constipation, and also helps to prevent you from feeling dehydrated. It helps you be hydrated. Okay, so you need all of this, right, in the correct quantity to have a balanced diet, and then you have a healthy life. Okay, this one I already went through. This one also kind of went through already, all the different properties and importance of fats and everything. Please go and read it yourself again. There's a lot more that I'm not able to say because of the interest of time. Okay, simple food tests, right? We can test for starch using the iodine test. So if the starch is present, the iodine will turn from yellow, right, it will turn to black. Then if I want to test for proteins, right, for example, like the chicken, the egg, kind of thing, right, I'll use burette test. What will I see? From blue, it will turn into purple. Okay, so that means if purple, there is protein. Lastly, oil, right? You just see an oil spot, lor. Very simple, oil block, oil spot. Okay. Next, we need to identify the basic information found on a food nutrition label, such as the carbohydrate, protein, fat, sodium content, serving sizes, percentage daily value, and energy content. Okay, so energy is in 2 units. Some countries use kilojoule, some countries use kilocalorie. Okay, Singapore we actually use kilocalorie. So how to count daily value is very simple, right? So for example, if in one day I'm only allowed to eat 100 grams of protein, okay, I'm only allowed to eat 100 grams of protein, but then I go and eat maybe KFC, I eat 250 grams of protein, right? I'm already over the limit, I'm above 100%. So how do I find out what's my thing? I will take 250 divide by 100 and then I'll times 100%. Okay, so 250 divided by 100 times 100%. I'm actually at 250% over the limit. Okay, so that's what the daily value means. Let's look at one more example. If let's say for example, in one day I'm only allowed to eat 100 grams of carbs. Okay, then I eat one potato chip, right? In a bag of potato chip, and inside the potato chip is 20 grams of carbs. Okay, 20 grams of carbs. So that means that this bag of potato chips, it has used up how many percent of my daily carb value already? Right? Simple. I take 20 over 100 times 100. Okay, so 20 divided by 100 times 100%. I got 20%. Okay, so that means that this bag of potato chips is actually taking up 20% or 1/5 of the daily value of my total carbohydrate intake. Okay, so that's how I calculate the daily value. Okay, and then all the information, things like serving sizes, things like energy content, you must be able to read. It's all the data is all there. You just need to open your eyes, look carefully, and you'll be able to see it. Okay, then we understand and calculate percentages and total amount of nutrient based on the serving sizes and percent daily value. Conversion is not required. Okay, yeah. So this is what we just did, right? I just showed you how to calculate the percentage of a nutrient based on its serving sizes. So like that, if you are only allowed to eat 100 grams of carbs, then you ate 20 grams. What is that percentage that you're actually eating? Okay, talk about how food with high fat, salt, and sugar content can cause health conditions. Okay, high fat, right? It will cause obesity. Okay, high salt, it can cause high blood pressure. And then high sugar can cause diabetes. Okay, we already talked in detail in class what exactly these 3 diseases mean and how they can affect you. So in essence, just remember fat, obesity, salt, high blood pressure, sugar, diabetes. Okay, what are microbes? Microbes are organisms that are too small to be seen with the eye, has to be observed. Okay, so anything that's a microbe, things like bacteria, even some funguses, things like viruses, these are organisms that we cannot see with our eye, right? So we actually have to use a microscope to observe them. Okay, what do microbes do? Firstly, funguses, they can actually form mold on bread. And then bacteria, they can cause the milk to turn sour. And then it will spoil the milk. If you drink it, you get food poisoning. Okay, so in order to preserve our food, we need to stop or reduce the microbial activity, right? Basically, we want to stop the microbes so we can preserve our food. There's 5 ways of doing food preservation. High temperature, including sterilization, pasteurization, and canning. So what is sterilization? Basically, you heat your food up to a very hot temperature, right, above 100 degrees. Then all the bacteria and all the viruses will be sterilized and killed. Okay, but that also might affect the taste of the food. Okay, then what's pasteurization? Is basically you heat up the food, or usually it's milk, heat up the milk slowly, and then you cool it down quickly. Right, so it's hot, then cold. That's pasteurization. Then canning is when you put food into a can and then you heat it up. That's it. Freezing, right? Using a low temperature, freezing, or very obvious. Reducing the water content by freezing, dehydration, or using chemical preservatives. This is, remember, in some food packet you got this silica gel to actually help to remove the water. Pickling is to lower the pH, usually use vinegar. And then reducing the oxygen supply by bottling and packaging. So these are the ways that you can prevent food from being spoiled. So why are food additives necessary? Right, it helps to preserve the shelf life of food. Okay, so if you don't have food additives, then you go supermarket, everything all rotten already. So you need food additives. Okay, these are the 3 food additives: preservatives, nutrient supplements, and texture and appearance modifiers. So preservatives, as I said, vinegar, salt, sugar, sulfur dioxide, these will help to increase the shelf life of the food. Now some food, like some cereals, they actually have supplements, right? They actually add vitamins and mineral salts into your food so that when you eat the food, you get more vitamins and more mineral salts. So it helps to boost your immunity. Lastly, things like texture and appearance modifiers, like starch and food coloring, is just to make the food look good, right? Look more appetizing. However, there are some non-permitted additives, like carcinogens, right? Carcinogens means cancer causing. That means that if you eat this food, it might increase your chance of getting cancer. Heavy metal poison, right? For example, mercury, right? So heavy metals are kind of metals that actually cause poison to your body. Okay, so these are not allowed to be used as additives. And also, we cannot exceed the level of certain additives. Okay, so why? Some of these food additives, right, they actually cause allergic reactions. That means that if you eat too much of this food, right, food additive, you will get, lumps on your body, then you got rashes everywhere. Okay, so that is why you must use the correct amount of food additive. Okay, and with that, we have come to the end of part 2 of this summary lesson, right? Even though I go through very fast, I still need you, right, to take your time slowly, read through the textbook, read through the notes, and then understand everything. If you need to, watch this video again, but this video is not a full everything lah. There will still be some things that I can't say due to lack of time. Okay, but I also want to keep in mind less than 1 hour. Anything more than 1 hour, I think, right, tired lah, the brain tired already. Okay, so have a good rest, and the last video I'll upload tomorrow. See you and goodbye.